In a previous video, I went out and explored the great wild outdoors, and I found a few palm trees that I was interested in the height of. And I gave you the answer, but I didn't show you how. So if you haven't seen that video, I'll go ahead and drop a link right now so that you can take a look at it, so that you can see where I got this data from. This is a real world situation in my neighborhood. So let's actually answer this question. Okay. So to give you a refresher, the idea of this problem is that I wanted to know the height of this taller of the two palm trees. For example, if I was a contractor that was hired to take them down, I would need to know how tall they were in order to be able to plan out how to cut it down. So I'm looking for the height of the tree. And what I did was I stood across the street, which was 27 feet away, approximately, give or take maybe a foot. And I used a clinometer on my phone to determine that the angle of elevation, so the angle from the horizontal, right? If straight forward is 0, then the angle of elevation is the angle that I'm looking up at the tree. And I determined, that that was 67 degrees. And I also mentioned that the spot that I was measuring from, the place where the clinometer was about 6 feet off the ground at my eye, right? I'm 6'3". My eye level when I'm looking up is probably about 6 feet off the ground. Okay? Now, this being a trigonometry word problem, probably not going to surprise you that we're going to use trigonometry. The question is, which trigonometric ratio do we use? And in order to do that, in order to figure that out, we need to start with, what do we have? And what do we need? Now, there's a whole other video on naming these sides, the opposite leg, the adjacent leg, and the hypotenuse. And I'll go ahead and drop another link right now to that video if you have a hard time, or if you don't remember that. So from this 67-degree angle, it looks to me like what we have is this 27-foot adjacent side. Adjacent leg. Now, I keep doing that. I keep saying adjacent side, but I really need to be saying adjacent leg, because if you'll notice, yeah, this 27 is adjacent. This 27 feet is adjacent. It is next to the 67-degree angle, but the hypotenuse is also adjacent to it. So I need to stop saying adjacent side and start saying adjacent leg. Call me out on that in the comments when it happens. Okay, so I have the adjacent leg, which I just use ADJ to abbreviate. I'm looking for this height right here, which is the opposite leg. And I'm not particularly interested in the hypotenuse. The hypotenuse would be like if I wanted to attach a rope to the ground, to the top of the tree, for some reason, then I would need to know the hypotenuse to find the length of that rope. Okay, so we know what we've got. We know what we need. The next step is SOHCAHTOA. Yes, I write it every single time. So we've got the adjacent leg. We need the opposite leg. Which one of these three abbreviations has both A for adjacent and O for opposite? TOA is the only one that has both the thing that we have and the thing that we need. Okay? So we're going to use tangent. But remember, Tangent is nothing by itself. We have to say tangent of, well, that looks like 67 degrees to me. So the idea is that this tangent of 67 degrees is the multiplier. It is the ratio between the opposite and adjacent legs. So we're going to plug that into our calculator in a minute. And that ratio is equal to the ratio of the opposite leg over the adjacent leg. So h is the opposite leg, divided by 6 is the adjacent leg. And then at this point, you can cross multiply. Don't forget when you cross multiply that if you don't have a fraction on one side, you still have a fraction on one side. You just have to put it divided by 1, and now, magic, it's a fraction. Okay, so 1 times h is h, that's nice. And I get 6 times the tangent of 67 degrees. Which makes sense, again, because tangent of 67 degrees is the multiplier to get from the small leg to the large leg, from the adjacent leg to the opposite leg. Okay, and now this is calculator play. So I'm going to jump over into Chrome. And I'm going to type in calculator. And it gives me this Google calculator. Now, if you're using this calculator, the first thing you absolutely have to do is look at this button right here in the very upper left of the calculator's keyboard. There are 2 buttons here. One says rad and one says deg. Deg stands for degrees. Rad stands for radians. They are 2 different units that you can use to measure angles. So far, we've only used degrees, so I'm going to hit that and see now how the degree sign is darkened, it's black, and the radian side is grayed out. You need to be in degrees or you're going to get weird answers. And that's kind of one of my big tips when it comes to these trig problems. If you get an answer that you really didn't expect, especially if you get a negative answer, I strongly suggest checking your calculator and making sure you're in the right mode. So it was 27 times tangent of 67, and I'm in degrees, equals 63.6. H equals 63.6 feet. So we're done, right? Well, no. But we're really close to done. We're almost done. Okay? Yes, the height of that right triangle is indeed 63.6 feet, but remember that I'm not taking my measurements from the ground, right? I'm not sticking the clinometer on the ground and measuring the height there. I am instead measuring from the height of my eye, which is, again, about 6 feet off the ground. So we're going to take that 63.6 feet and we're going to add the 6 feet for my height. So the tree is 69.6 feet tall. Nice. So I'm going to leave this up for a moment. Now, this video is going to be much shorter. I'm going to be releasing 3 or 4 videos for the rest of this week and a little bit into next week, but it'll just be one example problem per video. I'm getting some feedback that my videos are really long, which I'm totally down with. I will try to cut them into smaller bite-sized chunks. Thanks very much for watching. Have a great one. Stay safe. Class dismissed.